Hey class, Dr. Church, and want to talk today about some simple machines. One of my favorite subjects, obviously, since I'm a mechanical engineer. Um, it's kind of fun to talk about machines. And I have a video that I'm going to be posting up next where I have put a step on my pull-up bar. I think it's kind of a fun little video, and I'll have an assignment for you with that, just to identify some simple machines. So we're just going to jump right in and look at the 6 basic types of simple machines today. So what are the simple machines? Well, there's 6 kinds of simple machines. We're not going to do this today, but we can calculate ideal mechanical advantage for those machines, and then we'll look at compound machines. So I'll be giving you some of that a little bit later. So today, let's just look at the 6 different types of simple machines. Now, they're called simple because they are, in fact, simple. And they're all around us. You just don't necessarily look at these things as machines or things that give you mechanical advantage necessarily, but they in fact do. Okay, one of those, the first, is an inclined plane. You can determine mechanical advantage by dividing the length of the incline by the height. Now, you know that if you're trying to roll a heavy object or place a heavy object up into, like, say, a truck or on top of a shelf, it's very difficult just to lift it straight up because you're doing all the work against gravity straight up. Okay, so you have to, the output force, if you do a deadlift, then you've got to lift that weight straight up and you're lifting the entire weight. If you roll it on an angle, right, if you roll it on an angle, then it just makes it a lot easier to move that weight because you're doing it over some distance. Okay, you're doing it over a distance as you're moving that object up. So that's just a very simple machine. There have been lots of applications for simple machines, like these structures that are built. You know, you lift heavy objects to the top of a high structure by using an inclined plane. Very simple application for that. Okay, now when we do calculations in physics, science, engineering, you would look at the amount of force that's going into it and the output force that's coming out of it. Now, when you look at vector mechanics, which is something we're not going to do, but if you were to take physics at some point, we would take a look at that. And if we were in the class, I would show you a lab where we can actually measure those forces. But the input force, the force that you have to push to move the object up, is actually less than the force that will come out of that to actually lift the object. So there's a bit of a force multiplier. And that's what machines do for us. They multiply the forces that we put in, and in such a way that we can get a greater force out. And that's what mechanical engineers do. They design machines in order to give mechanical advantage because just like a pair of pliers, you can grip something much stronger with a pair of pliers. If you're trying to open the lid of a jar, you can put a pair of pliers on there and it makes it much easier. But that's a different type of machine. So, all right. So, example of an inclined plane, a ramp. All right, inclined plane is a simple machine that does what? It increases forces. All right, what's the second type of machine? The second type of machine is kind of similar, but it's a wedge. The ideal mechanical advantage of a wedge is determined by dividing the length of the wedge by its width. And one of the most common applications, actually using this the other day, I have one of these in my garage. It's just a wedge to split wood. And of course, a hammer gives you certain advantages as well. But it's just a very simple machine. It's the application of an inclined plane that moves. And you can generate a tremendous amount of force with a wedge. Another example is just a knife. That's the famous Marine Corps USMC K-Bar knife that is built by the company K-Bar. They're in Olinder, New York, and they've been supplying knives to the Marine Corps since the 40s. I have one of these. I gave one of these to my son. It's it's a pretty nice knife. It's well done. But the edge of a knife is an example of a wedge. A wedge makes work easier by changing the direction and amount of a force. If you think about this, it's just really kind of like an inclined plane flipped over, right? There's your inclined plane, but a wedge, ta-da, a wedge is a force multiplier. Your input force, because of this angle, will be multiplied so that you get a much greater output force. Now, we will learn at some point that the amount of work that you do, work is an energy concept, and work and energy are always conserved, but forces can be multiplied, and that's what machines do. The longer and thinner the wedge is, the greater its mechanical advantage. If you think about that for a second, a long, thin wedge versus like a short, fat wedge, this one gives you much more mechanical advantage because of the angles that are at work there. And again, we could calculate this in a very specific way, but we're not going to have to worry about that for this class. So a wedge is an inclined plane that moves. True, that is true. Which wedge has the greater mechanical advantage? Well, it's this one because it is much longer and the angles have changed. All right, third type of simple machine is a screw. Now again, this is a bit of an inclined plane that's worked into a helical design. Ideal mechanical advantage of the screw is the length that the threads are divided by the length of the screw. And so what you'll notice is that the way that the screw threads themselves are designed, right? The way that these threads are designed, that gives you a mechanical advantage. And it's really an inclined plane that just works its way up. So screws have different designs, but they can give us, again, another force multiplier. It's a simple machine just like the lid of a jar. That's an inclined plane wrapped around, so you can get that jar lid on much tighter. Excuse me. A screw makes work easier. I've actually got another example. Got another example right here. This is a clamp. Now this is the screw, and if I screw this in, if I put something in this clamp, right? Let's say I want to hold something in the clamp, then I can screw this. Okay, I can get that really tight, and I can generate a lot of holding force with that clamp. So this is just another type of just a simple machine. Now this lever, which we'll see in a minute, also gives me some mechanical advantage, but again, that's a simple machine. A screw jack, you can lift a car with a jack, and that's something I could also show you as well. Okay, screw's output force is greater than the input force. If we look at the pitch of the threads, and depending on how the pitch of the threads are designed, I can get a much greater output force. Now I have to turn this thing more times to lift it that distance, but that gives me mechanical advantage. Again, I just really want you to get the concepts of how machines use mechanical advantage and allow us to do things that we just really can't do without them. An inclined plane is wrapped in a circle. That's a screw. The output force of a screw is greater than the input force. And an example of a screw is like a jar lid. Okay, a jar lid. All right, the fourth simple machine, remember there are 6. This is the fourth of 6. Now this is a lever. You use leverage all the time. Ideal mechanical advantage of leverage is determined by dividing the distance of the fulcrum. So you know that if you've got this distance and then you've got this distance, and that's the fulcrum, it's the pivot point. This is going to be the fulcrum in this particular example. Okay. And then you've got the distance from here to here, it's going to be the input, and then you've got, oh, I keep grabbing the wrong thing there. And then you got the distance from here to here, and that's going to be the output. Okay, so we'll see that. You've got different classes of levers. It is just one type of simple machine, but there are 3 classes of levers, okay, where the fulcrum is moved. This is kind of like the teeter-totter example. You got a load and a force with the fulcrum somewhere near the middle. In this example, you've got a load and a force with the fulcrum down at the end, but you can also get mechanical advantage. And then sometimes your lever is attached to the fulcrum, okay? So let's see a couple examples of that. Your first class lever, again, like the teeter-totter, and you know that if you put a really heavy person on one side, this is not going to work. If you got a really light person on the other, but 2 kids that weigh about the same, you know, can use their legs and have some fun on that. If you're really, really heavy, you'd have to move down closer to the pivot point so that you wouldn't just toss the light person off of the other side of the teeter-totter, the seesaw. Another class of lever is like the wheelbarrow. I've been moving a lot of stuff around my yard with my wheelbarrow, and you see here's the fulcrum, right? That fulcrum is going to be near the wheel. The load is on the middle, and then you're down here on the end, right? But you can lift, even a small child can lift a pretty heavy load with a wheelbarrow. So that's a second class lever. And then the third class lever is like like a hockey stick, where you're inputting your force down here. It's actually pivoting around the point there, and your output is going to be in that location. So a fulcrum is the fixed point. The lever is the bar that moves. Some levers are maybe a hockey stick and a wheelbarrow. Where's the input? Here's the fulcrum. And this is output forces would be A, this is input, and the fulcrum is the pivot point. The fifth type of lever, got to move on a little more quickly here, is just a wheel and an axle. You get mechanical advantage because you've got effort that is putting in here with a long lever. All right, so you're using leverage and an axle, and you can lift a fairly significant load with that. Some simple machines that are wheel and axle, a screwdriver. Okay, you've got leverage with the handle around the pivot point, and it rotates on an axis. A pencil sharpener, something you see all the time, or like even a doorknob. And of course, on vehicles, you see wheels and axles all the time. You've got gear systems that are wheels and axles, and where the load is here on the teeth of the gear, and it pivots around the center point. And then, depending on the size or the number of teeth, you can get mechanical advantage there. And then finally is the sixth type of machine, and that's a pulley. Again, I'd like to have some videos later to show you some of these simple machines. You can get mechanical advantage with a pulley. Now, if you only have one pulley, the tension in this rope is going to be the same as the tension in that. But if you have a double pulley system, you can actually half the load or double the amount of force that you can exert with a pulley. So there's all sorts of machines that use pulleys, like these cranes will use a double pulley system in order to lift some really heavy loads, or like that. You've got pulleys that change the amount and direction of the force, and again, we can calculate that. We're not going to go through all those calculations. If I were in class, I would attempt to show you that, and I've got some pulleys in class that we can do some experiments, which is pretty fun. But again, I just want you to identify the 6 basic types of simple machines and be able to recognize those when you see them. And then for pulleys, I do want you to know that if you have a single pulley, the loads are going to be the same. And if you could pause this video and look at that. Like if you look at the load here, and then compare that to the load, compare that to the load here, you see that's the same. But when we do that same thing here, we'll see that the load is going to be, the load in each of these is going to be different. So that would give me the 100 newtons that you see there, that this load is halved with a two pulley system. And in this system, when we've got a 3 pulley system, it's divided by a third, and you can guess that if we had a 4 pulley system, right, it's going to be divided by a fourth, right? So that's just the way that works. It's a pretty simple calculation. So those are just some simple machines. Those are the 6 types of simple machines, and that's what I wanted you to be able to identify. So thanks for your time and attention. And I'm going to post up my little work video, and then your assignment is going to be to identify some simple machines there. So I should have that by the end of the day today, and hopefully you can work on that tomorrow. I hope you guys are doing well, and I look forward to seeing you soon.